Hey Algebra 1 students, it's Mrs. Thomas. So today we are going to go through our first lesson on numeric and graphic representations of data. So make sure you have out your class notebook so that you can write these things down. Go ahead and pause the video to at least go ahead and write down the title, jot down these that we're going to do some definitions for, and maybe just example 1. You might want to leave some space before example 2, or you can pause later and write it once you're done with example 1, whatever you prefer. So, first thing we're going to define is a sequence. And a sequence is a list of numbers each number is called a term. So first term of the sequence, second term of the sequence, you can see the sequences down here. So this sequence, we've written out 4 terms. Each of those numbers is a term. Common difference is the difference between 2 consecutive terms. And consecutive means next to each other. So if we were looking for the common difference in this first sequence, which it will ask us to do, I would be taking second term minus the first term. So if you want to write that down, second term minus first term. A common difference can be negative, which I know seems kind of weird for some people, but you can have a positive or a negative common difference. Next thing we want to talk about is an expression, because you're going to be asked in ones like example 2 to write an expression that will give you any desired term of a sequence. So an expression is a math phrase, not sentence, a math phrase that may contain numbers, variables, and operations. So the reason why I say phrase is because I want to kind of put it in an analogy with English. So in English, you have phrases and you have sentences. And the big difference between those is that your sentence is going to have some sort of end punctuation, a period, an exclamation point, a quote, question mark. Same thing with expressions. A math phrase, no equals, or greater thans, less thans, etc. It just has the numbers, the variables, and the operations, no equal sign. A variable, if you didn't know, is a letter or symbol used to represent an unknown quantity. All right, so let's take a look at what you're going to need to be able to do. So example 1, given the sequence, determine the next 2 values. Identify a common difference if one exists. So in order for it to be a common difference, the difference between 2 consecutive terms has to stay constant. So we could say common or constant difference. So sometimes the difference doesn't stay constant, which means that it's just a different type of sequence. So we're going to look here, determine the next two values, so 4, 8, 18, 25. So if I'm looking for the pattern, which all of your sequences are going to have some sort of pattern. If I'm looking for the pattern here, it looks like I am increasing, so my numbers are getting bigger by 7. So 4 plus 7 is 11, 11 plus 7 is 18, 18 plus 7 does give me 25. So the common difference, which is 11 minus 4 or 18 minus 11, because it can be any two consecutive terms, the common difference is 7. And we just use the lowercase variable d to represent common difference. So in this case, it's 7. The next two terms, the next two values in the sequence, if I continue my pattern, if I add 7 again, that gives me 32. And then if I add 7 again to that, that would give me 39. So 32 and 39 are the next two values. The common difference is 7. In the sequence in B, looks like here my values are decreasing. So to go from 13 down to 9, that would be going down 4. 9 to 5, also 4 down, and then 5 to 1, also 4 down. So if I continue the pattern, 1 minus 4 then would give me -3. -3 minus 4 would be -7. So those would be our next two numbers, our next two values. The common difference is negative this time because 9 minus 13 is -4. All right, next one in C. I'm starting out with a negative number and they're getting more negative as I go. So this is a decreasing sequence. From -3 to -5, I subtracted 2. Then here I subtracted 4. From 9 to -17, I subtracted 8. So there is a pattern here, but there's not a common difference. So once you figure out what the pattern is, you just continue it. You don't have to identify your common difference in this case because this sequence is not what we call arithmetic. Arithmetic sequences are the ones with a common difference. So here I went down by 2, then by 4, then by 8. So 2, 4, 8, I'm multiplying my amount that I'm subtracting by 2. So then if I follow that pattern, the next time I would subtract 16, which would give me -33. And then the next time I would be subtracting 32, so -33 minus 32 would give me -65. So these would be the next two terms in my sequence. I don't have a common difference to identify. All right, next one. These values are increasing, they're going up. Here I went up by 3, then by 5, and then by 7. So that pattern, I would guess that the next time I would go up by 9 because 3, 5, 7, 9, so just odd and increasing. So 9 plus 16 is 25. Then the next time it should be 11. So that would give me 36. The other pattern that exists here, if you're just looking straight pattern and not necessarily looking at the amount that you're adding or subtracting, is that these are your squares. So 1 squared, 2 squared, 3 squared, 4 squared, and that pattern works as well. 5 squared, 6 squared, we get the same thing. No common difference here. It was changing each time, so we don't need to do that part of the question. All right, last one. For the sequence below, write down the common difference and use it to write an expression to determine any term of the sequence. Finally, find the 30th term. So first thing I want to tell you is that if you're writing down a common difference, then that means that the sequence is arithmetic, which means that there is a formula that we can use to write the expression. So the formula that you can use is first term plus common difference times n minus 1, where n stays your variable. So in this case, I look at my sequence and it's going up. Here I'm adding 6, adding 6 again, adding 6 again. So it does have a common difference of 6. So if I use that to write an expression that will give me any term of the sequence, my expression should be first term, which was 3, that's the first term of the sequence, plus common difference, which is 6, times n minus 1. Now, of course, we need to simplify our expression. So here we need to distribute our 6 through. So 6 times n gives me 6n. 6 times negative 1 gives me negative 6. And then I have these like terms to combine. So 6n minus 3 would be my expression. The reason why we want this is where n is the term number. So it says, finally, find the 30th term. So the 30th term, I am just going to plug 30 in for n. So n equals 30. So 6 times 30 minus 3. 6 times 3 is 18, plus add the 0 there on the end, minus 3. So that gives me 177 for my 30th term. Typically in fancy notation, they would, say this is called a sub 30. So hopefully that gives you a pretty good understanding of sequences and expressions. You could always, if you had the time, write out 30 terms of the sequence to find it. That's perfectly acceptable work. This just takes a little bit less time if you can remember this formula. All right, that's it for 1-1. So you should be set to go ahead and do your practice. Please make sure that you let me know if you have questions.